The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is context sensing APIs and other tools to get your Android apps to market faster. Our guest speaker today is Sukrut HV, who is a technical consulting engineer in Intel. Sukrut HV is working as a technical consultant engineer at Intel Software and Solutions Group. He is associated with Intel Developer Product Division from past 4 years. He has completed his BE in computer science from VTU and is involved in helping customers to optimize and improve the performance of their applications using Intel tools, and he's also involved in supporting embedded and mobile customers using Intel System Studio tools. He's also involved in IoT Maker community. So without further delay, I introduce you all to our guest speaker. Over to you, Sukrut.
Yeah, thank you, Vishal. Okay, welcome. So today, as Vishal said, we would be going to discuss about the various tools. So I would categorize it as a software tool. So various Intel software tools for you, the greatest mobile developers that we have. So the main reason that we have put as a context sensing APIs is one of the favorite APIs that I could say for the mobile developers to basically deploy the compelling apps into the Android market or any other app market, right? So basically we would speak about more of these tools and the methodologies that we have from Intel side. So I would be categorizing about which are the tools and for which particular aspect of it, and where do you exactly use these tools to develop your compelling applications. So without much further delay, as Vishal has already been introduced, so let me just get into the slide deck. So now we have Intel software tool suites that are basically helpful for the mobile developers as well as the embedded developers. So if we see, I've categorized into we have a two tool sets. So one is Intel INDE, Integrated Native Developer Experience, and then we have Intel System Studio. So we would be briefing about these two tool sets. So by end of this presentation, you would be capable of understanding what are the various tool suites and what are the various tools and methodologies that Intel provides in terms of these two tool suites, and you should be having a brief idea about how do we use these tools and what are the various aspects and what are the various usefulness of these particular tools. So we first get started with the INDE, that is Integrated Native Developer Experience tool suite. So many developers have this particular question as you have many device targets and you have many issues with that particular stuff. So what are the various issues that we have, right? So if we come onto the right-hand side, we have seen that we have basically categorized the issues that usually the mobile developers face in this particular arena, right? So that is difficult to reuse. Just to give you an example, you have to take care your application runs seamlessly across multiple target devices running, it might be an Windows operating system, iOS, or an Android. Or if you have taken a multiple architecture, it might be Intel x86 or it might be any other architectures like ARM or any other architectures. So in this particular aspect, then you will have this particular ambiguity as how do we reuse the code. So we wanted to address this particular issue, and then coming to an IDE, Integrated Developer Experience, right? So basically, many of you would be using the tools. Sorry. So many of you would be using various IDEs for developing your mobile applications. It might be ranging from Visual Studio or Eclipse or Android Studio. So we thought that let's make the experience better for the mobile developers by giving an option to the various the integration into the various IDEs. So now with Intel INDE, you can integrate into either Visual Studio or Android Studio and even an Eclipse. Right, so that's one of the flexibility that you as a mobile developer will get when you want to use INDE. Then comes to our next, the segment where you want to differentiate your app when you want to deploy it in your in any of the Play stores. So how do you differentiate your app? So the differentiation comes in a way of how do you optimize it, how fast your application is, how well is it being optimized in order to take the complete advantage of your architectures, and how well it's been designed, right? So for this we have various APIs and technologies like OpenCL for native applications, and even the context sensing APIs, which can basically sense the context that your application in and then act accordingly, right? So with the usage of various of these such technologies, you can make your app compelling by making it more faster and working seamlessly across various platforms. And then coming to the last segment is where debugging. Debugging is basically one of the toughest part for most of the developers. Once you're developed your application and you find that your application is intermittently failing, then you wanted to do a debug. Then we also thought that okay, let's give this the various debugging tools that can help you as a mobile developers to identify these various issues or the bugs very quickly and make your apps go into the market very faster. Right. So with that, let's get deeper into the Intel INDE system, Intel INDE platform suite. So basically, Intel INDE is help you to write your codes both in C++ and Java platforms and across, and you can deploy it across an operating systems and across architectures, and not only on Intel architectures. And we have some APIs like context sensing and other APIs which can be useful in order to generate a compelling app across architectures. So that's why we give a tagline as cross-platform and even the cross-architecture tools. Right? So we have broadly classified or segmented as what the developer needs. So one is the cross OS and cross architecture. So long back, if I remember, so we had actually a survey where most of the mobile developers were frustrated in order to develop their or reuse or recode their application, the same applications across architectures or across the platform. So they requested that it would be really nice to have a tool set which can help them to develop their applications and deploy it and optimize it across the architectures and across the platforms. So that's where Intel INDE can, we thought that Intel INDE can be helpful when you're developing an applications on an Android platform, which you can deploy it on Intel as well as in ARM architectures. Then we also thought that at the same time the performance has to be improved, but the developers has to have a various tools which can help to improve the performance of their particular applications within a very less time, because time is very critical when you're developing your applications, and you should be fast enough to develop your applications and then release it to the market, right? So time is the money here. So we thought that the performance has to be gained within no time. So that's the reason we thought that okay, let's also give some of these tools which can help them to develop their native applications faster by utilizing the various technologies like OpenCL or OpenCV, and then the various libraries that we are going to discuss in another couple of minutes. Then, as I said, the developers would be really used to a specific IDEs. Let's say, if I'm a Microsoft or if I'm a Windows developer, then I would be very familiar with the Visual Studio, and I'm pretty much flexible as where to go and what options to tweak. So I would be preferable. It would be really preferable for me to have a Visual Studio IDE in order to develop my mobile application. So in that case, we also have a wide variety of IDE choices ranging from Visual Studio, Eclipse, and even the Android Studio. So we thought that okay, IDE would also be one of the great options to help customers or to help the developers in order to create a compelling apps. So coming to developer tool set, then we wanted to categorize the tools into 3 different categories or segments, right? So one is a build, debug, and then analyze, right? So when you as a developer, how do you get started with an INDE is just to, while installing, you select your flexible or your preferable IDE, right? So let's say if I am pretty much flexible with Android Studio or an Eclipse, then I can pick any of these, and automatically during the installation, all these tool sets will be integrated into your preferred IDE. So with that, you can start building with by adding various of these APIs, and you can take advantage of like OpenCL or threading libraries or performance primitive libraries, and we'll just go in depth about what exactly are these libraries and where exactly it can be helpful in order to improve the performance of your applications. And then once you have built your native applications or even your SDK applications by using the libraries and other stuff, then you can go and debug your applications if in case you have any issues with your particular applications or native applications. So you can do a live debugging right from your Visual Studio and so on. And then once you are done with your debug and your application is now ready, and then you want to analyze. So analysis is very important in order to find out how well is your application is taking advantage of the underlying architecture. So you have your platform, you have your app, and you want to find out how is this particular efficient utilization, because ultimately your end user would have paid for each and every of the IP blocks or the graphics or whatever it might be in your architecture. But if your particular application is able to take advantage of each and every of these resources that's been lying in your phone or in your tablet, then that makes a lot of difference with your particular application. So these are the various segments that we have categorized. So these 3 segments, and we have the tools in to help the developers in each of these segments. So this is what I was speaking about, the IDE integration. So if you see on the left-hand side, I hope you would be seeing this installation screen. So here we have the wide variety of choices for the developers to select their IDEs. So if you are a developer who is very well versed with the Visual Studio, usage of Visual Studio, then you can use the Visual Studio. Or if you want to continue your development using the Android Studio, you can do so, or even the Eclipse. So some developers, they are pretty much comfortable with the command lines and they don't want any integrations, then you can just skip the integration of the Android. So that's the 4th option. So with each of these integrations, there are some requirements that's been there. So for example, if it's for the Visual Studio, you need to have the 32-bit JDK installed, or if it's been the if it's been the Android Studio or an Eclipse, you have to have a 64-bit JDK being installed. So also, if you could see on the below screen, we have a small checkbox to asking you a permission whether you want to enable the HAXM. So which we are going to discuss about this in a couple of files, which will basically helpful in order to make your emulation faster. All right. So as you are done with this, you just select it and then click on next. Then you don't really need to, you just sit and relax, and you'll automatically the installation will be done, and all the necessary the components of the this INDE packages will be automatically installed, and you will have the flexibility to just take the APIs or the frameworks and then integrate into your applications. So as I said, if you are a developer using a Visual Studio and very much well versed with the Visual Studio, and you want to, really build your application, debug your application right from the Visual Studio, then you can do so. So as you could see, you can just the project properties are pretty much similar as what you would be seeing in your Visual Studio. So we'll be able to find out what are the project properties and what are the target architectures that you want to really deploy your particular applications to, and so on. And you can, and one more good thing, the beauty of this is you can even start debugging your Android applications directly from the Visual Studio. So that's the live debugging that you can do by using a Visual Studio. So these are the various flexibility that you have, and you can do the development for both the Windows as well as an Android applications using C and C++. So again, the way that we have designed is such a way that the integration while you are installing the INDE package, then it will automatically install the ADT and the NDK, the latest ADT, NDK, and even the VS Android plugin, right? So these are the various steps which you will be automatically installed. So you as a developer really doesn't need to worry about which is the latest version, where do I download it from, how do I import it, and so on. So all this jugglery is been over. So now with the Intel INDE, you will automatically automatically able to customize, and you will be able to install all these automatically while the installation itself. So you have even the option, let's say have an Android NDK. So if you don't want to download the NDK and install it, since you have already downloaded the package, then you can just go to a customize option, and then you can uncheck the NDK installation, and then you will be automatically asked for your NDK download, and you can just point the installer to the download, and it will automatically pick that particular NDK. So this is one of the flexibility that's been there. So where you have one package, and then it will automatically take care of everything that you require for your for building your application. So basically, you as a developer doesn't really need to worry about which tools should I have, which plugins should I install, and so forth, right? So we have taken the complete care. So once the installation has been done, then you can start developing your application. So that's our main agenda in order to, that's our main focus in order to give the integration support for the various Android developers. Okay, so with this, now I'll get deeper into the various features of the Intel INDE. So one first feature that I would like to highlight is the Open Computing Language, or the OpenCL Code Builder. So if you have come from the high performance computing or the enterprise applications, then OpenCL was one of the highly used the libraries that I can see, or the APIs, which is helpful in order to share the workload apart from CPU to the various IP blocks or the graphical processing units, or the GPUs, right? So basically, if you see, all the developers or any of us would have been paid for our architecture or the platforms, but how well are you utilizing all the architectural IP blocks, or it might be the graphics blocks and so forth, right? So you have paid for this particular hardware, but how are you efficiently utilizing it? So there comes the responsibility of the application developers or the mobile developers, as how well your particular application that's been deployed can utilize all these hardware architectures, right? Or even the hardware platform real estates. So that's where OpenCL is one of the INDE API blocks, which can help you to offload some of your compute intensive code onto these graphical units, and you will be able to seamlessly work or share the workload on both CPU as well as the GPU, right? So with that, we have one thing to highlight here is the OpenCL 2.0. So with the latest OpenCL 2.0, we have a concept called shared virtual memory. So the flexibility is that previously with OpenCL 1.2, if you have any pointer related data structures, then you have to really change your algorithms if you want to share this particular data structures between your host and your target, right? So or I mean to say between your CPU and the GPU. So in that case, it was quite difficult because you need to do all these source code changes and other stuff. But with the OpenCL 2.0, you have the shared virtual memory concept, where you can put your pointer related data structures in the shared virtual memory and seamlessly work with that particular data structure across your host as well as your target, right? So that's one thing. Then you have the OpenCL code builder, again, that's been part of an integration, and then you can have this kernel builder or OpenCL the code builder as part of the IDEs that I have already discussed about. And as I said, the one major stuff is it works seamlessly across the platforms, that's on both Windows as well as an Android. So you can use the OpenCL if you're working on either creating a Windows apps or even on the Android apps. And even you can take the advantage of the latest architectures, like if you see the Intel Core M processors or the Intel 5th generation core processors, then we are ready with the OpenCL. So OpenCL can even take advantage and build seamlessly on the Core M processors. Then comes the next feature that we have that has been part of Intel INDE is the media for mobile. So we wanted to give an applications the seamless the media related applications a flexibility, right? So you can develop your applications which is based on the media or across the platforms. It might be iOS, it might be Windows, or it might be Android, right? So the couple of features that I would like to highlight here is, let's say you are developing your application where the camera capture or the video transcodings or the transcoding applications applications, transcoding was one of the important applications. Then you would be using the media extensions that we have, and the couple of features that I would like to highlight here is the video streaming. So let's say, let me give you a scenario that you are developing your application or a mobile application where you are taking your video streams, and then you want to do this video capture a live stream, right? So how do you do that? So you can use your application and get the video streams through a camera or the inbuilt camera of your mobile or a tablet. And then we have this third-party streaming engine called Wavza, which has been giving support for Intel INDE, that you can take these the video streams that you have, and then you can seamlessly integrate it with your application with the Wavza, such that these video streams are put it in Wavza streaming engine, and then you will be able to do the live stream of your particular videos that you are taking it from your application. And one more thing to highlight here is the audio content recognition that is being again delivered by a third-party vendor called Audible Magic. So here you would be able to help, you will be able to develop your applications with this added functional where you can do let's say, just to give you an example, you can develop your application which can react based on the audio content, right? So you can just say, okay, open, so it's like an okay Google or whatever the Siri kind of stuff, right? So you can do an audio content recognition based applications also. Then the main thing to highlight here is we have several samples for these media for mobile, which clearly describes about how do you get started with various of these particular media SDKs or basically the media codecs that we have. And then it's been open sourced and it's been developed. Some of them are developed by Intel and open source community, and then it's been completely validated by Intel. So we have all this set of the open source samples being put in a Git repository. So you just need to Google it for software.intel.com/INDE, and then you will be able to see a various list of documented articles and samples and how do you work with these particular samples. And the media for mobile can again work across iOS, Windows, and even the Android target devices across Intel architectures and beyond. Okay. So coming to context sensing SDK, that's again one more feature that I would personally like, and that's been part of INDE from past the last version of INDE, right? So context sensing APIs or the SDK is basically helpful for you, the mobile developers, when your particular application is in such a way that it has to recognize the context where your application is being used and then react accordingly. So just to give you an example over here, so if you see a small picture that I have posted there, so when you are driving and you get a call, so how you can create a real engine or the rule engine where you create a code segment using a call sensing API, say that, okay, when I get a call in this particular context, the context here is when you are driving, then you should automatically send a message, or your application should send a message saying that, I'm driving, I'll call you later to the person whoever have called you, right? So this is one example. So in such a, this is just a call sensing API, but you have several such sensing APIs like a location sensing APIs or a pedometer sensing or even the call sensing APIs, so on, right? So I'll just give you a list of it. So in a couple of files. So this is very important, and this is where you can really differentiate your app, right? So you can just integrate your context sensing APIs in your particular application, and then you can give a really good experience for the end users who are using your particular application. So this works on Android. So we have the complete context sensing APIs ready for Android, and it's coming soon for the Windows. And with this, you will be able to get the various access to the sensors of, internal Intel sensors, and you will also can get the various data as when at what particular point of time, where were you, and so on, and then you can just put all your data and do the analytics by using an Intel Cloud as such, right? And this can be there are various compiling apps. So just to give you an example, right? So as soon as you enter into an office, then you have to recognize the context of your office and then change your particular phone context according to your office. Let's say as soon as you enter your office, then you have to make your mobile or to go to your the silent profile and then switch on the Wi-Fi and connect to the employee hotspot automatically. So you can do all these context related functionality by using the context sensing APIs. Right. So since I was not able to give you a live demo over here, so what I've done is these are the various samples. As I said, it's all been open sourced. So I've taken one of the context sensing API sample, and then I've just run this in my tablet, and I've taken the snapshot of it. So if you take the first one, the location sensing API, right? So I have the latitude and the longitude being picturized, and then I can take the lat and long, and then, as I said, you can create your apps such that in this particular location, how do you want your app to perform, and what are the various data that you have to push into the cloud, or how do you want to do the analytics of your data and so forth. And then you can also use the parameter sensing as how many steps you have walked really and how far you have walked and so forth. And then the terminal context, like how is your device is being placed now. Is it been a portrait or it's been a landscape? And if that's the way, if it's been portrait, how your application or the app should look like, and if it's on the landscape mode, how you want to rearrange your various widgets and so forth. Right. And then one more thing is app sensing. So if you want to find out that, okay, when your particular application is being launched, then you want to, let's say, push some advertisements or push something, or push some notifications or something, then you can sense the application. So as soon as your application has been launched, then what do you want to do, right? So you can even sense the application, and you can sense the battery, right? So you can find out, okay, if the battery or the temperature is changing, or if the temperature is more than 30 degrees Celsius, then what do you want to do? And you want to automatically switch off some apps or the background apps which has not been active for so long. So you as the developers has a wonderful ideas, and then the context sensing APIs are basically helpful when you want to really materialize your particular ideas, and that's where the context sensing can be very helpful. So just to give you a sample, right? So here is the application sensing, app sensing API. So what I do is I'll just first authorize my application to the various to get the access to the various sensors and other stuff, and then I'll enable the sensing. I'll start the daemon enabling enable the sensing, and then add a listener. And then as soon as I launch an application, so the application that I've launched is by name called app sensing sample, right? So you could see a small toast that I have already highlighted in a red color oval shape, where I just written a toast saying that new current app name, and then as soon as I open any app, then it will show me, it will display the app name. So you can basically take this, right? So I have just given that toast, but you can take this app name, and as I said, you can work on the various ideas that you have, like as soon as your application, your app is open, then you want to push particular ads and so forth, then you can do so. So that's basically an or the overview of the context sensing APIs and how it can be really helpful to make your apps compelling and differentiating in your Android market or any other market. Then comes the the couple of beta features that we have. So it might be the tamper protection. So this is again the beta feature that we have. So tamper protection is basically very helpful when you are working with your highly secured app, or you want your applications to be more secured and free from the various hackers. So with the tamper protection, or the tamper protection, as I said, is part of an INDE. So as soon as you install INDE, then you will also have the crypto, or I can basically say a special type of an obfuscating compiler, which will really insert a lot of code, which makes the reverse engineering for the hackers very difficult. So we have various samples and videos about the tamper protection that's been there. So you can just, as I said, go to the software.intel.com/INDE tamper protection, and then you will be able to find a huge set of documentation there. So due to the time constraint, I'm just briefly explaining as what is the tamper protection basically. So as I said, it makes the reverse engineering very difficult, and also to just give you an example, so it can really be helpful if you are if the hacker is trying to change the code at the runtime, because it's not only trying to modify or monitor your code at the compile time, but also at the runtime. So you'll be able to monitor your code by using the various the features of the tamper protection, and then you will be notified that if any modification is being done by the hacker, then it'll automatically stop, and then it'll say that there's some intervention that's been done by someone else, right? So basically it can helpful in various of these protections. It might be the IP protection, or it might be a password protection and content tamper and anti-privacy. So it's very easy to start with, and we have several APIs, and the compile, as I said, you can compile your application with the compiler that we have, and then you will be able to, and the compiler will automatically insert the various code in your particular application, making it more robust from the hackers. So coming to the next set of tools, that is compiling. So when you are developing your applications natively, right? So then that is where you use GCC compiler. So if you have anywhere worked with creating the games, right? So most of the Android games are running natively, and if it's been developed using an NDK, so NDK by default uses the open source GNU GCC. So you can replace this with Intel C++ compilers, and you could see a pretty good performance improvements when you are working with the native applications. So just to give you a small benchmarking result over here, we have taken a small spec of the benchmarking, and then we have run the same spec benchmark with Android NDK running GCC 4.9. And we have normalized it to 100%, and then we have taken the same workload and ported out with the Intel C++ compiler, and we were seeing that around 31% improvement that we got to we got without much of the source code changes, right? So this is Intel C++ compiler, which will be very helpful with the various of your native applications when you're developing basically in a C and C++. So when this particular Intel compiler is being coupled with the various libraries, you will be having an advantage, or the extra advantage. So before going to that, I also said that we also have a specific tools for helping developers in debugging, right? So one thing that we have is the visuals, the GNU GDB that's been part of the installation, so which can be helpful in order to debug your native applications. So with the Visual Studio, as I said, you can do the real-time debugging. So you can integrate. So with the INDE installation, you will be also have the GDB being integrated into the integrations like Visual Studio, and you will be able to do the debugging of the native applications. Right. So with that, let me go to the next slide. So as I said, when you couple your Intel compiler to take the advantage of the the one of the famous libraries, or I can say the famous libraries in the other domains, like if your application is really dependent on image processing or a computer vision, cryptography kind of data workloads, then you will be able to use Intel performance primitives, or IPP, right, integrated performance primitives, and then you'll be able to get the advantage. The reason that I'm saying is because IPP has been really designed in such a way that by the architects that it will take the advantage, and it's been hand coded in an assembly to take the complete advantage of the Intel architecture, right? So we have made sure that you are taking the complete advantage of all the resources that you have, all the registers, all the core architectures that you have, and that's where it's been highly efficient. So the one goodness about this is the same set of APIs can work seamlessly across platforms like Windows, Android, and even on the Mac OS X. So you can just take the same application and then use it across the platforms. So coming to the next feature is Intel threading building blocks. As the name suggests, it's basically used for threading. So many times we have seen that the customers has been struggling while developing their application using threading methodologies. So they might be using the POSIX or the Win32 threads, where you need to create your threads, maintain your threads, and then you need to automatically take care of the load balancing. So what I mean by load balancing is that you have a specific workload, then how do you distribute this workload in a multi-processor scenario, right? Let's say you have a 2 cores or a 4 cores, and how do you take your workload and give it to all these 4 cores and make sure that all these 4 cores are highly utilized, right? So that's where the threading comes into picture, and in this particular multi-processor or the multi-core era, you have to make sure that you are doing the load balancing properly. So that's where the threading building blocks is, which works on the task level parallelism. You really don't need to create your threads and do stuff, right? So it will create your the TBB or the thread building blocks itself will create its own thread pool, and then it will automatically do the load balancing for a given workload of C and C of C++ workloads basically. So one more good thing about the TBB is that once you have made your application, threaded, you'll also see that the power consumptions can be also reduced and also increasing the responsiveness, right? So since you're making the work parallelly, then you don't have these responsiveness issues, because many a times people complain that their native applications, they are seeing the responsiveness issues because even though they have the flexibility to use all these multiple threads, they would be using a single thread or a single core, right? So that's where you can really make your apps differentiated by utilizing the threading building blocks, and it's been also open source now. So coming to the the hardware HAXM. So in many a times we have seen that you don't have the device, and you want, let's say you don't have an Intel Atom based device, and you want to find out how exactly is my application performing on an Intel devices. Then in that scenario, what you can do is you can enable the HAXM. So the beauty of this is it can gradually increase the boot up. I mean, it can basically make the boot up times very less. So if you have if you have any time experience by deploying your emulator, then you would have seen how long it would take, maybe around 40 seconds or a minute to start your emulator and then come to our home screen, right? So when you enable an HAXM, so it's an hardware related the feature where if you have your laptop or a PC which is being based on a core Intel processors, and the VT or the virtualization technology being enabled, then you can really take the advantage of it, and then you can see how fast is your emulator booting up, right? So that's where it will be very helpful, and the HAXM based emulator will also support the OpenGL ES 2.0 workloads to be emulated also. So this is really very important if you are really frustrated about the booting times and the way the emulator really responds to your particular touches, or it might be the way it responds to your application user interface, right? So that's how you can use the HAXM to really get almost, I don't say that it's almost equal to the real device way of responsiveness, but it can it can be equal to, somewhere equal to the real device responses. Right. Then comes the system analysis. So these are the various tools which will be helpful in order to categorize. So now we have finished the build and the debug set of tools, and now we have landed up in an analysis set of tools, right? So now we wanted to categorize. Okay, now you have developed your application, but you wanted to figure out whether your particular application is taking advantage of all the resources in your underlying architecture. How do you do that? So here we have the system analyzer, so it can give you the real-time data. So as you could see in the screenshot there, it's showing the various metrics and the graph that is being the real-time graph that's been there with your Android application. So you just need to connect your Android device or to your host system, and then in your host system or your laptop you can deploy the system analyzer, which is being part of your INDE installation, and then start your application. And as soon as you start your application, then it will show you which are the various metrics. So we basically use this tool to categorize whether your application is the CPU intensive or a GPU intensive. So if it's basically a CPU load intensive, then we have a tools called Intel vTune amplifier, which can help you to find out what is happening at each particular source level. But if it's on the GPU level, then you will be able to find out what is happening at the pipeline, right? So without any source code modifications, then you can do a lot of experimentation, saying that okay, if my particular application is really a pixel process compute intensive, then what should I do? How do I experiment it? So we have several overrides. Let's say you can just enable the 2x2 textures, and you will be able to find out whether your GPU workload is being increasing now or decreasing now, or how is the GPU cores being utilized, whether your GPU course is being idle or if it's been active, and so forth. then comes the the same set of application you can use. So if you see that, let's say you're running your particular graphics application, and then you see that with specific frame that you see automatically the GPU core spikes up, right? It uses a lot of GPU, or like let's say 80 or 90% of your GPU core. Then what you can do is just capture that particular frame, and then you can give it to a frame analyzer, and that's again part of an INDE. So this frame analyzer will be able to find out what is happening inside your graphics pipeline, whether it's a shaders, or the vector shaders, or the primitive shaders which is causing an issue. And you can, as I said, you can also do a lot of experimentation. So let's say if I do a 2x2 textures, and if I see a real improvement. So if you could see, there's a small green color lines showing the delta, right? So it says that okay, before doing this particular experimentation, if let's say if I have enabled the 2x2 texture experimentation, then it will automatically say that okay, this is the performance gain that you get when you don't have, let's say, pixel shader, or when you bypass your pixel shader or a vertex shader and so forth, right? So if you could see, I've taken a small frame there which is a lighthouse frame, and then I wanted to know the various metrics which are really important, or which are responsible for the only lighthouse. So that's why you see that lighthouse has been highlighted in pink color. So now I'll be able to find out in my whole frame how much is my lighthouse frame is taking, right? So what are the various metrics for that? So even if you could see the bar graph on top of it, only the yellow part that is being highlighted is for the lighthouse frame, and then I'll be able to find out what are the various APIs that is being used, and various metrics, as how long is my execution units inside the graphics engine is been sitting idle or inactive and so forth. Right, so that's the importance of frame analyzer, and you can use it on both the DirectX APIs, which is been on the Windows applications, or it might be even on the OpenGL applications. Then you will be able to use the graphics analyzer. So once you are done with your graphics or a frame analysis, then you will be able to get onto the platform analysis. So how would be platform analysis helpful? Is basically it can help you to map how is your CPU and GPU interacting, right? So which are the various tasks, and how long is these tasks been working? Let's say you as soon as you touch on your application, or touch on launch your application, how long does it take to get from the pause states to release state, or again if you just click on the back arrow, and then how long it takes to come to a real state or a life cycle events, right? You can find out what's happening, and how long each of these tasks is been executing, right? And how much of the CPU time it's been taking and so forth. So just to give a summary of an INDE, as how do you start is basically while installing, you select your Intel, the various IDEs of your choice, and you also have an option to work on a command line if you don't want to really work within IDE. And then once you are done with that, you will be able to create your Android applications or a Windows application by using various of these APIs. It might be like media for mobile, context sensing APIs, or the threading building blocks, or the OpenCL, IPP, OpenCV, and so forth, right? And then once you are done, you have created your application, build it by using if it's been a native application, then you can build it by using Intel C++ compiler. And then if you have any issues, then you can debug with you can do the real-time debugging with the Visual Studio plugins, that is basically with the GDB. And then once you're done, you can use the various tools to analyze. So as we have already discussed, you can use the system analyzer to categorize whether it's a GPU load or a CPU load, compute intensive, and then you can take a particular frame which is causing a glitch in your in any of your metrics that you see in system analyzer, and then you can find out the various issues of the OpenGL that's been happening in your in your particular frame. And then once it's been done, then you can use the platform analyzer to find out of the various tasks and how long your particular tasks has been running, and how long how much of the CPU it's been utilizing and so forth. So if you could see, there is something that's been highlighted in and it's called as ULT or Pro, right? So ULT is basically an ultimate edition, and the Pro means to say the professional edition. So we'll just see what exactly are this in our next slide. So this is about the product summary, which is giving you an high-level overview of what are the various hosts it supports. So you can just start developing your application right from your Windows or your Apple Mac OS X, and the target that we support is Android right right from 4.3 to 5.0 based on ARM as well as an Intel architectures. And you can also develop the applications which is being based on the Windows. And we have several SKUs. That's what I was speaking about: the starter edition, professional edition, and the ultimate edition. So both the starter and the professional edition are free, and you can even download the ultimate edition, which again comes with a cost, but you can get the evaluation of 30 days for free, right? And then we have a various ways of supporting. So right from the forums, premium supports, and the technical articles that we have. So we have the next slide. So this is basically a slide which is speaking about the various editions and what are the various features that we have. And so this is basically, as I said, the starter and the professional edition is free. And if you are really developing your applications in natively using C++ compilers, IPP and TBB, then you have to go to the ultimate edition, right? Apart from that, I think everything rest is being part of the professional edition also. So let me just now go. This is some of the just a small slide speaking about how do you contact us, right? So if you have any questions or any issues with the Intel INDE installation, or even with the using the features, APIs, and so forth, then you can contact us at indie@intel.com. Right. So just to end this and give some time for the Q&A, I'll just give you a brief about the Intel System Studio for Android. So Intel System Studio is again, it has the same set of tools as what we have in INDE, but the two differentiating tools, or two or three differentiating tools that I can point out here is the JTAG interface, or the system level debugging. So if you have any issues while developing your Android bootloader or a BIOS, then you can use the JTAG debugger and then do the system level debugging. Or if you have any issues in terms of a performance, and one thing to highlight here is the energy profiler. So because energy, the power consumption is really an important criteria in an handheld or a battery powered devices, right? So that's where you will be able to find out which is your particular, in which particular application function or so forth is causing most of your energy consumption, right? So you'll be able to find out all those stuff. And then again, as we have already discussed, C++ compilers, the IPPs and HAXMs are again part of the Intel System Studio. And all these tools that I have discussed about, it might be the the C++ compiler, or the IPP, or even the TBB for threading, and even the energy profilers, the system analyzers, the system debuggers, the frame analyzers, platform analyzers. Everything is Android Lollipop ready, and even the 64-bit ready. So because it's using the ART, the advanced runtime, and we are ready to it. So you can develop your applications which is capable of running in Android 5.0. So that's what I basically had for today's presentation, and I would again give for another 10 to 12 minutes to the Q&A. So just let me see.
So thanks for the insightful presentation. Let's quickly take up the questions now. Please read out the questions and their answers so that all our users may listen to the commendable insights.
Okay, so there's one question. So Android applications, how do you measure a CPU and GPU intensive? So okay, that's a good question. So basically we have one question as how do you categorize it as, right? So we have a tool called Intel System Analyzer. So Intel System Analyzer would be a right tool for this particular aspect, where you just give your Android application to it, and then it can tell you that whether your particular application is CPU intensive or a GPU intensive. So if you could see the graph, right? So you can just drag and drop the various metrics over there. So two such metrics is the GPU core and the CPU core application intensive. So if you see that your application is, when your application is running and you see a glitch in the CPU, then it means to say that it's a CPU intensive. And if you see a glitch in a GPU core, then it means to say that it's a GPU intensive. So that's how you categorize whether it's a CPU intensive or the GPU intensive of your Android application. I hope I answered your question. And there is one more question. So can you again throw light on various performance metrics of your application? So just to reframe this question, right? So if you have the various performance metrics, right? So what I mean by that is, if I take your application and with the system analyzer that you found out your application is a CPU intensive, right? So in order to find out what are the various metrics, what I do is in VTune amplifier, which is a performance profiler, I'll give my Android application or the which is being based on the native development or NDK. So I give this native applications to the VTune amplifier as a process, and this particular VTune amplifier will find out the various metrics. For example, the metrics are the cache misses, right? So how many cache misses has been happened when your application is trying to fetch some data and that data is not being there in your L1 and L2 caches? How many of your data requested has gone till RAM or a primary memory, right? So how many of the TLB, the translation look aside buffers, has been there, which is going to your SD card or your hard disk, right? So these kind of the various metrics and the various hotspots, CPU times, right? So you want to find out, okay, if I have a small function which is called, let's say, draw, right? You have a draw call which is taking so much of CPU time. How do you find out that, right? You can just give your Android process tied up to your Intel VTune amplifier, then you will be find out that what is the various what's the CPU time and how many instructions or how many clock ticks has been executed and so forth, right? So these are some of the various metrics, like as I said, the CPU times, the cache misses, the TLB misses, the translation, which are the translation look aside buffers, which will be useful for the the address translations between your virtual and the physical address translations. So these kind of the metrics, right? So VTune is a huge tool, right? It can throw you a huge set of information, and you will have, as I said, VTune can be helpful in both the software as well as in hardware metrics. You will be able to find out the minute details, that what's happening when your particular application is running in terms of an architecture, as well as your lightweight information in terms of an hotspots, so which is the functions which is taking most of your CPU time and so forth. Yeah, these are the questions that I had. So that's I think if you have any more questions, then you can feel free to post these questions at intel at indie@intel.com, and then we'll be able to answer most of your questions, right? So that's what I had. I hope you enjoyed the presentation.
I am really thankful to our guest speaker Sukrut for conducting this webinar. It was indeed a great session. I also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com very soon. Thank you all.
Thank you.